Hello, welcome to a C++ tutorial. Today will be the first episode I do on this tutorial. I'm going to be doing C++ and basic tutorials in the upcoming weeks. And I call this the intro. And what I'm going to do, I have a small PowerPoint with a few slides only on C++, and then I'll do a Hello World application that we can see how it works. And that will be the introduction for today's C++ tutorial. Here on the screen, I have a typical pointer program. It's just a partial screen using IOStream, using pointers, but that's not the Hello World. Don't worry, this is a little bit more advanced than the Hello World program. So why C++? Well, there's a lot of features of C++. Number one, it's simple. A lot of people think that C++ is hard, but in reality, after basic, I like C++. It's one of the most simplest program. Can it get complicated? Can it get hard? Of course it can, but it's always basic in Pascal and Python and even HTML. It can get very complicated with CSS and all that, PHP, whatever you call it, you name it. It can be complicated, but in reality, it's very simple. It is compiler based. It uses dynamic memory allocation, has recursion. It is fast, extremely fast. It is object oriented. I'm not going to be doing object oriented programming in the beginning, but eventually we'll get there. This tutorial will take us all the way to the complexities of C++, and we will cover object oriented programming in the future. It is case sensitive. There's a very rich library. In addition to, you can make your own, add more library modules to it. Mid-level programming, and is portable. Before I continue, let me tell you, I'm using a Macintosh, a MacBook Pro, not a Macintosh, it's a MacBook Pro with the M1 processor. And that's what I'm going to be. I'm using CLion as a compiler I'll be using for my demonstration. But anyways, that's the reasons why I would use C++. It is very, very easy and powerful. So what I'm going to do now is explain a few things, just basic stuff. If you want to make comments in a program, you use a double slash for a single line comment. If you want to do a multiple line comment, you start with a slash and an asterisk, and you end it with an asterisk and a slash. You can do multiple line comments. C++ uses what is called preprocessor directives. Those are the includes that you see in many C programs and C++ programs, typical of both of them. In C++, IOStream is the basic include. It's the one that has your C out, you C in, and while in C, for example, it uses stdio. So they use a different include, but for C++, it is IOStream. Another thing, the difference between C++ and C is the namespace. Once C++ got standardized, we start using namespace. In Borland's Turbo C++, for example, which is, I normally use Borland for my examples, I didn't have to use namespace. So I can do C out and hello world without any problem. In C++, now that it's standardized in CLion, which is what I'm going to be using, I have to use namespace. So I'll be doing the using namespace std. So I'm telling C++ to use that namespace called stds or standard. And then I can do something like C out hello world. Now, could I do without it? Of course. I can just do std : C out hello world. It is the same. With or without namespace, I would have to say where C out is. Another thing to notice here is blocks of code in C++ as well as in C. The code start and end with a bracket. Everything in between the brackets it's code that is a block. And statements end with a semicolon. So if you ask for a function, if you do an assignation, it ends with a declaration, a variable, all of that. They end with a semicolon. That's what we use both in C and in C++. All functions return a value, including main. Now, one thing that is very common between C and C++, they both start the program with the procedure or the function called main. Now, you can do a void main in parentheses, and it won't return anything. I don't recommend it. It is normally better to just make it an int, an integer, and then return a 0 if you have nothing to return as a value. And that makes it more consistent. But there is the void variable that means nothing is going to be returned. So the main syntax of a C program or a C++ program is int main, then whatever's in the brackets. There are more components. We'll do a hello world after this PowerPoint, and you'll see that how it works. The strings are included within double quotes. If it's a single quote, it will be a character, not a string. Then we have cout. Cout is the standard way to send out information to whatever namespace I'm using, in this case, standard STD. Cout, then we put the less than symbol twice, and then whatever is there, it will type it in. Hello world, for example, that will print out hello world. I can also do cout hello, then double quotes, and then hello world. And it's the same. Now, the cool thing about cout is an object is that I can put in, as you can see in the example right here, I am, then close my string, 32 then years old. And it will work. I can put anything because this object's made so they will take any kind of variables. Now, speaking of variables, if we want to declare a variable, you do the var type, then the var name, and we can have multiples in semicolon. For example, int a declares an integer, or I can do int a comma b equals 4 comma c, that declares 3 variables where b is initialized to 4. Or I can do a Boolean, is in this case. So that's how you declare a variable, and we'll go over variable types as we go along the scenarios here. In the integer world, these are all the different integers that you can do. You got short ints, unsigned short ints. By the way, anytime you see the unsigned, any of these unsigned, it means, for example, from negative 32,000 to plus 32,000. But if it's unsigned, it's from 0 to 65,000. So that's not the only difference. Same amount of size in the typical variable size, 2 bytes in this case. But you add these two numbers, that will give you the unsigned starting from 0. It makes it only positive numbers, basically. A regular int, it goes from this -2, 147, 43, 648, all the way to 647, or the unsigned, which is the big number here. We have long ints. We have unsigned long ints, and then we have long ints, and this is a very huge number. And then we have unsigned long ints. So these are all the type of ints. Now, by the way, these are all whole numbers. If you can see, there are no decimals. For that, we would have to do like floats or doubles. Okay, we'll go over those. Strings, anything that it's in a double quote. A string is a series of characters with a null character. This is a character, var equals a, but hello is a bunch of characters and it ends with a 0. Now, it is not important at this point to notice this 0 here. It will be in the future, especially when we start manipulating strings, and more specifically when we start working with pointers. That's one of the reasons why C and C++ are powerful, is because of the pointers. And then the nulls and the zeros and all that becomes more important. But at this point, hello, look at it this way. This is probably the easy way to remember that it's a string. It's between the two quotes. So it's there, the /0 is there, but don't worry about it for now. Now, thankfully, the smart people that make all these C standards and all that have given us the include string. This makes it so easy. Instead of doing putting a bunch of characters together like I have here, for the first time, now we have an object, we can do string variable 1, variable 2 equals hello. Just like I did on the ints, I can declare things of type string. Instead of having an array of characters, I actually have a string. And then we now jump to the floating points. I was mentioning before, we have single precision float. We have a double precision, which is a double, or a long double precision, which is a long double. And this is the size. And look at the numbers from -3.4 e to the -38 to to the 3.4 to the 38. This is huge number, but this one's even bigger, from 1.7 to the negative 308 to the positive 308. Again, huge numbers. So yeah, you're not gonna have any trouble doing any calculations with C++. We also have Booleans. Booleans are standardized now, so we can actually use the values true or false. True or false. And we'll see more of that later. To determine the size of a variable, we can use the size of. And basically, if we say something equals the size of, and then put in the variable name here, it will give us the value. We can use the cout object to calculate that. For what we're doing in the first few tutorial chapters, we won't need that because we don't care, basically. But as programs get complex, I mean, I'm not going to get to that point in this tutorial, but when memory matters, that's when size of is very important. Of course, you have your basic arithmetic, like any other programming language. Have your plus, your minus. This is obviously your multiplication, the asterisk, the division, and the modulus. A lot of people don't use this. They don't know why. They should use it more than often. 7 modulus 3 is 1, because that's the remainder. 7 divided by 3 equals 2 with a 1 remainder. Modulus is the remainder number. We can also have constants, like const double the tax, 7.75, or double pi equals 3.1415926, and I can keep going. And I'm missing a semicolon here, but yeah, you can do these constants in the within your procedure functions. Like what they call ternary. It's basically an expression, and you've seen this. Looks like old fancy. With a question mark, and then some value if it's true and a value if it's false. Think of this. This is a typical example. You say max, and max is a function, by the way. Max is the name of the function. And I'm saying if x equals y, the double equal sign is the equal in Boolean. If, and then I have a question mark, if it's true or if it's false, both values. So this, I will be doing examples of this in our next chapter of the tutorial. Today I won't be covering this one, but this is the main way it works. So, and we'll, instead of making now, if it was something simple, I use this. If something more complicated, I actually do a function. Now we get to the input, CIN, C-I-N, or CIN. And CIN is the opposite of cout, obviously cout. And I'm going to put CIN, and then it goes into a variable. It could be a single variable with a semicolon, or it can be multiple variables. It is valid as long as I put in commas when I'm entering the values in my return key. Then we have what's called typecasting. Don't worry too much about this one. It's important to know it, but don't worry about it too much. Let's say I have a double M, and then I can say M equals the static cast, and then it's double of this. So I'm forcing one set of numbers to another. This one is not too obvious of why I'm doing this from a float to a double, but this one is. I'm declaring CH as a character. There's a C in a single quote. And I'm saying, look, static cast int, that's the variable of CH. This will print out the number 67, I believe, the number for the letter C, whatever the letter C value of the ASCII value is, that's what it would do. This is more obvious example. Typecasting we'll be using probably in the second or third chapter of these tutorials. So then another thing that C++ is known for, and so is C, by the way, C already had this, was the combined assignment. The plus equal, negative equal, times equal, modulus equal, divide equal, and all that. So x plus equals 5 is the same as x plus 5. Or a slash equals b is the same as a equals a slash b. So it's a combined thing, and we'll be using this in the future as well, probably starting with chapter 2 as well. Now, to formatting, we can do some very fancy formatting in C++. That does require IO manipulation, IO manip. And there's a few ways. If you want to do it only for one number, you can do the set W, where X is the value. For example, cout, and then set W5, and then A, and then set W6 and 23. So it's using 5 spaces for A and 6 spaces for 23. That's what that is. This one only affects this one, and this one only affects this one. Now, if we want to do it, we can do set precision X. That's the number of fixed numbers, so decimals, think of decimals in here. And then we can do a show point where we tell it to always do the decimal points. We're going to be doing this examples with this and then also in the next chapter. But for here, to align all floats and force to 2 decimals, I would do something like cout, set precision 2, and fixed. And that will force it to do all floats and have 2 decimals. It can align it. Think about like doing a table in a spreadsheet. And this is what you can do. You know, here's the string manipulator, set W for N, fix, show point, set precision, left or right, because you can force it to be left or right. A few other commands are important. We got the get line. It's used to input sin, but does not ignore spaces or tabs, whereas sin does. Or we can do sin get line where you put the variable in limit, or get line sin and variable. Either way works fine. And to read a single character, you can, you know, obviously char ch. I can do sin greater than ch, or sin that get blank, or sin that get and then ch. All of these are the same, by the way. They do the same job, which is basically like when you want to wait for next key press, you know, that will do the job. And string operations, look at this. We have string name, and I put my name is Ray. Now int size, because it's an integer size, name that length, and it tells me it's 3 because there's 3 characters, R-A-Y, 3. That's what this will declare the size. I'm declaring this the int and giving it telling it where to get the value in the same declaration. Also, if you want to do string manipulation to add them, str1 plus str2 is the same as plus equals str2. So as you remember the operators that we can do, combine them, it works for strings as well, which is easy. Again, C++ is easy. If we include CMath, we can do sine, cosine, tangent, square root, logarithmic, and absolute values. On the cstdlib, we have our random generation. We can do random numbers and initializing the random number so it does different initialization every single time. This we'll be using also in the future, not in today's chapter. And that's the end of the PowerPoint. So how about a real life example? We're gonna do an hello world. And so yeah, let's check it out. All right, so here we are in my C compiler. I'm using CLion. It does the job. I have a MacBook Pro using the M1 Max chip and the 16-inch laptop, and it's April 21st of 2022. And I'm going to start my program with a couple of comments. Hello World by Ray Ojeda. Both C++. And I'm going to do another comment. MacBook Pro, 16-inch M1 Max, CLion IDE, using CMake, which is on a Mac, and GCC is my compiler. I'm going to do some includes. Include IOStream. That is the standard C++. And you know what? Cout is the normal method for printing information, but what if I wanted to do printf? Printf is a C function, not a C++, but I can always do stdio and used for C's printf. And sure, why not? And I'm gonna include string. I need to type it correctly. There we go. I'm mostly gonna be using namespace std. So here's my main my main program, int main, and I'm going to return 0. Remember, it's an integer. I'm going to do string name, string declaration. So I can do something like printf. I'm going to do /n/n. I didn't put that in the PowerPoint, but /n/n is basically a new line. I'm going to break a couple of blank lines, and I'm going to put in hello, what is your name? And I'm using printf. Printf is a C function, but I can do printf because I'm declaring stdio. So there you have it. I'm gonna do syn to name. So I'm gonna put in my name into the console there. And then I'm gonna do cout /n/n means do 2 empty lines. Hello. And look what I'm gonna do here. I'm gonna put my name. And then I'm gonna do an L. And I didn't include an L on my other, on my PowerPoint, but L is end line. It's the same as putting a /n, by the way. It's just 2 different ways of doing it. Very simple, hello world. Again, double slashes are comments. IOStream is used for C++. stdio is for C, and string, right? Oh, and stdio, I'm going to do that H because it's a C function, not a C++. So there. And I'm going to do string. I got namespace std, so I can do the cout and the cin without putting the std : I'm using printf because I can get away with it because I'm using stdio, and I'm doing hello world. So let's do this. Let's go ahead and run it. I'm going to save all my files. I'm going to run it. And here it is. I'm going to put Ray Ojeda. And it says, hello, Ray. There we go. Now you notice how I put my first and my last name, and it only did the first one. It's because I'm using syn to a name. I could have done a different way with the get line, but for this point, for this example, this works okay. This is fine. Again, include IOStream for C++. stdio is for C. I don't need it. I'm just using it. And string is just to make my life easier. Namespace std. Here's my string declaration. Printf. The only reason I can use printf is because I'm using stdio. Otherwise, I would have to do cout. Hello, what is your name? And then, of course, inputting send into the name, and then doing this. And very simple. So there you go. This is my first introduction to C++ for you guys. I'm going to try to do a chapter per week. Next week, we'll go a little more in depth into C++. I'm going to try not to mix C and C++ that much, but every now and then I'll do it. You know, it's nice to be able to do both. It's the best of both worlds. Again, I'm using CLion for my IDE. Because I'm using a MacBook Pro, I have to have CMake, and I'm using the GCC. All of this is free, by the way. All of them are free. GCC, CMake, CLion just to make the IDE easier. But I could always use a notepad file or some program that will make a text file and use CMake and GCC, and it will work just fine. But this is a lot easier when you have an IDE. I hope you enjoyed this Hello World, this introduction to C++. And until next time, if you liked it, please like and subscribe, and you know what to do. Thank you.